Okay, good morning everybody. This is my second video. Last class we did one questions, and here we are going to study about the relative density of liquid. There are two methods in A-level syllabus to find the relative density of liquid, that are U-tube method and Hayes apparatus. Hayes method. So first I am going to explain about U-tube method. In this U-tube method, first you should know what immiscible liquid only immiscible liquid only suitable to perform these practicals, because if it is miscible liquid means we can't use this method. So the first thing, immiscible liquid only suited to this method. Okay, then here there are U-tube here, two different liquid we need. So in which relative density we are going to do, so that liquid you need. Likewise water. So here I use, there are two different liquids. One is water and the one is liquid. So when you look at this diagram, you can realize the liquid density is higher that of water. Okay, later I am going to explain why I told like. Okay, and in this practical you need what? U-tube, which should be mounted with the vertical frame scale. Okay, appropriate scale, and two different liquid and funnel, because you have to pour the water into both ends, both open limbs, through both limbs. So that's why you have to use the funnel. So these are the basic necessary, not a basic, necessary instruments you need to perform these practicals. Okay, so first I taught what immiscible liquid only. So if the liquids which are mixable we can't use, miscible we can't use to this practicals. Okay, so immiscible liquid only used to this practicals. And first we have to pour denser liquid we have to pour into the U-tube. So why? If we use the less denser liquid in first, what happened? Both liquids should be divided in both arms. So that is a meaningless, isn't it? We can't find the relative density of the liquid. So both side, less denser liquid is divided into both arms. That's why we can't use. And first we have to what? Firstly we have to pour denser liquid. After that, less denser liquid have to pour into the U-tube. So that is the first step. And here in this method we have to take more than one reading. So one reading not enough, so more than one reading. If you take more than one reading, what is the if take more than one reading, we have more than one results. So we can plot, isn't it? We can graph, we can make the graph, we can draw the graph, then you can find the correct value, or almost correct value you can get. That's why we have to define what? Independent variable and dependent variable. Here you have to think independent means what? If we change the liquid column in one liquid, so that is that want to give the different reading. So isn't it? So that's why here we have to make the change of liquid columns. For that, if you make less denser liquid, if you add more denser liquid, what happened? The common interface is raised by some height, and it's not make any changes in the liquid column. So we can't get the different value. That's why we have to pour what? Less denser liquid. We have to add less denser liquid. What is the purpose? We have to add less denser to different reading, to get different reading. So these are the these are the steps we have to follow to get the relative density of liquid in graphical method. Okay, so in we can get using one reading, but it's not exact, it's not correct value, it's not give correct value. So if you want to get more reading, we need what? More reading. That's why we have to go graphical method. If you want to go graphical method, we need more readings. To make the readings what? If you change one variable, the another variable or independent dependent also want to get the different reading. But if you add denser liquid, if you add more denser liquid, it not make any changes in the reading. That's why we have to use what? Less denser we have to add. Okay, so I already sent you sent these notes, isn't it? I already sent the notes. Here I am going to explain part only here. So first arrange the apparatus as shown in the figure. I clearly explain. U-tube, you should what? Use what? Mounted U-tube, which what? Vertical appropriate scale frame, and two different liquid. Here arrange the apparatus as shown in the figure. Measure the, after that reading. We need reading to find the relative density. So here HW, HL. So the HW stands for what? Water column, of a length of water column, and HL length of liquid column. And here you have to take these two reading. The readings are taken from the common interface. Look at here, common interface. What is the common interface? When both liquid are mixed, because it is a immiscible liquid, that's why it's not, it doesn't mix with each other. So that's why this is what? Common. So these liquid are divided in this phase, so that's why we call common interface. So the liquid length are the liquid length readings are taken from the common interface. Look at here, HL. From the common interface we take the reading. So from the common interface we took the reading of water column. So water column HW from the common interface. And if you want to change by changing the amount of water, so by changing the amount of water, repeat the experiment and obtain several values for HL, HW. So how do you obtain the difference reading? By changing the water, we repeat the experiment and we obtain the different HW and HL. So we can obtain the several readings in this method. Okay, so now here very important things. I already taught what? The water is less denser that of liquid. So now we are going to find how it's possible. Look at here, I already taught H rho G. H rho G, isn't it? The hydrostatic pressure equal to what? H rho G. Look at here, at the same level of liquid, the hydrostatic pressure are equal. Hydrostatic pressure are equal in the same level of liquid. Hydrostatic pressure are equal in same level of liquid. So when you look at this common interface, at common interface the hydrostatic pressure are equal. So now look at here, at common interface I just mark here A points, here B points, A points and B points. So these 2 points are in the same level. So the pressure at A equal to pressure at B. So when you take pressure at A, PA equal to pressure at B. I already taught this is indicate only for hydrostatic pressure, and already we know what the atmospheric pressure also there. So we have to add both. So when you take at the pressure point A, pi plus and HW, the density of liquid rho W G. Okay, pi plus HW rho W G, that is equal to pi plus liquid height HL rho L G, pi plus HL rho L G. Now equate, so HW rho W G equal to HL rho L G. HL rho LG. So here GG cancel. Now already I told what the water is less dense that of liquid. Look at here, rho W rho L, HW HL. The multiple of density and height equal to other multiple height and liquid. So if HW is high, what we can say in other hand, rho W should be what? Less. HW is higher that of HL. HW is higher that of HL. It means HW greater than HL. Here when you look at this liquid column, you can compare. HW is greater than HL. What we can say in other hand, rho W should be less than rho L. Rho W should be less than rho L. So from this we can deduce the density of liquid is higher that of the water. Okay, that's why we changing the length of water column to get the different reading. If we change in liquid, what happen? Liquid is what? Denser. That's why it's going to what? Rise. It's going to raise the common interface half of adding liquid height. Suppose if you add x centimeter cube, the common interface should be raised by x by 2 centimeter. Understood? So that's why we can't get the different reading changing the liquid, changing the length of liquid. Okay, so now we got, so these things you don't need. So to explain to your understanding purpose, I put that one. So now HW rho W, HL rho L. Now tell me, what is the relative density? Relative density means what? The density of substance over density of what? Water. So now here rho L means what? The density of liquid. So then if you divide by rho W, it's give what? Relative density. But we can change what? We can change HW to get the reading. So that's why HW should be independent variable. HL should be what? Dependent variable. So we have to rearrange to graphical method to graph. So HL is the independent variable. Sorry, HL is the dependent variable, and HW is a rho W over rho L. Rho W over rho L into HW. So this is a graphical method. We can represent these terms, these quantities are in graphical method. So HW equal to X, this one gradient, and this is what? Dependent. So Y equal to mx, isn't it? So you have to write all these things, but clearly I sent you WhatsApp group, isn't it? The notes sent to you. So that's why I am going to raise the some part. Okay. So now we have to graph here dependent independent variable. So here x is what? HW, independent variable, and y is what? Dependent variable, HL. So the graph y equal to mx, and m is what? Rho W over rho L. M is what? Rho W over rho L. We know what? Relative density equal to the substance density over water density. So we have to interchange, isn't it? Denominator, isn't it? Want to change. So for that 1 over m. If you put 1 over m, it's changed. Rho L over rho W. Okay. So rho L over rho W is equal to what? S. So 1 over m equal to S. So you can say S m equal to m equal to 1 over s, isn't it? The gradients give to us what? 1 over relative density, or relative density equal to what? 1 over m. Understood? Very simple things. So here you should know 2003 past paper questions. If you do that questions, you can understand. So after finishing this theory part, you should do that questions. I will explain. Okay, so here what are the necessary steps? First we have to mount it, isn't it? The U-tube should be mounted with what? Appropriate scale, vertical scale. Okay, after that we have to put two different liquid. We know if you want to find the relative density of liquid, you should have what? The liquid and water. It's better, isn't it? After that what? First we have to pour denser liquid, and secondly we have to pour the less denser. That is the normal steps. After that, if you want to take more reading, we have to add what? Less denser. So another important things, the liquid column lengths are measured from common interface. Common interface means what? Two liquid meeting area, isn't it? Two liquids meeting area is called what? Common interface. So all liquid lengths are taken from the common interface. Okay, so that's thing you can use. So and we can find the relative density using this graphical method, and if you know the gradient of the graph, you can easily find the relative density. Okay, these are the important thing and main point. This method is suitable for liquid which don't mix. Immiscible liquid only this method. Okay, if it is mixable, if the liquids are mixed, we can't use this method, isn't it? If it is mixed, we can't use this method. Immiscible liquid only we can use. And in this experiment, more denser liquid should be poured into the U-tube first. I already explained that one. If not, less denser liquid will be divided into both arms of the tube. I already told. Okay, so I hope all you understood the practicals, and now we have to move to the next practical. Okay, so I sent you a WhatsApp group, so you have to write clearly, and I am going to move to the next practical. So next practical is what? Determination of relative density of liquid using a Hayes apparatus. We call the experiment name is Hayes apparatus. Okay. So first we have to draw the diagrams, Hayes apparatus. Okay. So determination of relative density of liquid using Hayes apparatus. So Hayes apparatus. Hayes apparatus. Hayes apparatus. So now look at here. First we have to arrange the apparatus as shown in the figure. So this method is here. There are two tubes. So there are two liquid used, and the two liquid are connected by which one? The wires. Here you should know what we can use miscible liquid. So that is the major difference in between the Hayes apparatus and the U-tube. What is the major difference? Here also we are going to use same things, graphical method. So we are going to find the relative density using the graphical method. Here also we are going to take the two different reading, independent, dependent. Okay, but the major difference is what? In U-tube method we can use miscible liquid. In this Hayes apparatus method we can use what? Miscible liquid also. Here major drawbacks of this practical is what? So there is a surface tension. Still we didn't study that one. Surface tension is different for liquid. So liquid to liquid the surface tension is different. Here is a different surface tensions water. Here is another surface tensions value. So it's caused the practical. But we take more than one reading and graphical method. Graphical method means what? More than one reading, 4 or 5 readings we need. So that's why the surface tension is what? It's not effect to the graphical method. So that's why we use what? Graphical method. So you should understand the surface tensions errors here. But to solve that problems, we use what? Graphical method. In graphical method you can what? Avoid those kind of errors. Understood? So same ideas, graphical method and same independent dependent variables here, and we have to make the changes liquid height, length, and we obtain using the graphical method. That is also here, but major difference is what? Miscible liquid can use in this method. Okay, so this is the steps. Arrange the apparatus as shown in the figure. Lose the clip. Here in U-tube method, how do we make the changes in liquid column length? We adding, or isn't it? We changing the less denser liquid column. So due to that, the another liquid also, the denser liquid column also get the changes. So that is the method to change. But here we are going to suck the air using the clip. So we can use what? There are two methods. Using the mouth we can what? Suck the air, and or we just lose the clip and we can remove the air, isn't it? Suck the air. So due to that the liquid column is get the change, isn't it? So when you make the changes in the clip, so when you lose, what happened? The air is evacuate from the tube, and the liquid column lengths are get the difference height. So this is the method to make the changes. Okay, so arrange the apparatus as shown in the figure. Lose the clip, then suck air from the tube, then close the Okay, measure the height of the liquid column. HL and HW. HL stands for what? Liquid length of liquid column, and HW stands for what? It stands for water liquid columns, and water column HW. Repeat the experiment and reading, isn't it? Repeat the experiment and get the several reading. We can get the several reading using this and HW, HL. So we can graph. We can interpret to the graph and we can get the answer. So now look at here. I just put A. Here B. Okay, A, B. So the 2 points which are located at the same level of liquid, same height level of liquid, same height level of liquid. So what we can say, the pressure is equal at the same height of the liquid. So now we can write PA, the pressure at point A equal to pressure at point B. Okay, same height level, liquid level, the pressures are equal. So I thought what here P, I mark P. It means what? In the tube pressure is what? Equal. In any in a whole region of the tube, the pressure is equal. When a liquid if a liquid is cover some portion of the tube, the hydrostatic pressure is what? Make the changes. So here inside of the tube P, okay. After that what? Hydrostatic pressures. You have to what? You have to take in your account what? Hydrostatic pressure also. So here P plus hydrostatic pressure is HW rho W G, that is equal to P plus HL rho L G, isn't it? P plus HL rho L G. When you look at this formula, PP cancelled and GG cancelled from the equations. So the remaining terms is what? HW rho W equal to HL rho L. Now look at here. Here independent dependence, we don't need the independent dependent. Why? When you shock the air, the liquid column will be get the changes. That's why we can take anyone as independent dependent. So relative density. What is the relative density? Rho L over rho W, isn't it? Rho L over rho W give what? Relative density. So here you can change rho L over rho W is what? Gradient. So HW equal to rho L over rho W into HL. HW equal to rho L over rho W into HL. So HL is what? X. Rho L over rho W is what? Gradient. And HW is what? Y. So Y equal to mx. Again we got same graph. What is that? Y equal to mx plus c. So here x is what? HL. M is what? Y is what? HW. And the graph is linear graph. And the gradient is give what? Relative density of the given liquid. So the gradient M equal to rho L over rho W. So that is equal to for relative density of the liquid. Understood? So I hope all you understood about this practicals. What is the method? Here we don't need the x and y variable. Why? Both are get the both liquid columns are get the changes simultaneously. Once we shock the air, it's get the change. Again, if we hard a little bit make air, more air we evacuate from the tube, what happened? The column length is get the different. So it's depend on the remove air. So that's why what here we can get the changes. And here, very important point is in this practical, it's suitable for what? It's suitable for what? Immiscible liquid also. And it has in this practical has a small drawback is what? There is two different liquid we use. we keep the two different in the two different vessels. That's why due to that additionally it gets surface tensions. So the surface tension is differ with liquid, so that is caused in one reading. But here we graphical method, more than one reading we get. Due to that we can we can neglect the surface tensions problems. Okay, so now I am going to read the important point. This method can be used for two liquid which are miscibles. That is the important point. And since liquids in the limbs are different, the limbs also different, and surface tensions effect would not equal each other, but we using graphical method. So therefore surface tensions effects don't affect on the results. And another important things, these questions asked in 2009 structure. So they ask the first question is, what is the diameter of this tube? So most of the students write more than 2 centimeter, 5 centimeter, 10 centimeter, like that. So it's indicate what they don't handle they didn't see, isn't it? They didn't see the apparatus. That is the thing. So here you should know what the diameter of this tube is, around 0.4 centimeter to 1 centimeter. Okay, so this is a 0.4 centimeter diameter tube. Okay, understood. So in next video, so I'm going to wind up this video, and in next video I'm going to discuss two questions and Archimedes principle. Thank you.